In this lecture, we're going to continue on from where we left off last time. We just finished cleaning and preparing our data, so now it's time to actually create, train, and test our machine learning model. Let's move on over into Jupyter Notebook and get started. Okay, so here I am back inside of our Jupyter Notebook file. I just carried on from the same notebook as last time, but I've removed all of the code for this second part, and then we'll work through it together now, step by step. As we've mentioned, one of the most essential steps in producing a regression model is to create our training dataset in order to teach the model, and then a test or validation dataset to compare the model's predicted results to the actual results, so that we can see how accurate our model is. In this case, our dataset did actually come already split with a test and training data CSV file. However, splitting our data is a very important part of the machine learning process for supervised learning, so I'm going to go ahead and split our dataset again regardless. This isn't ideal, as we're already working with a small dataset, as it's already been split, but as this is just for demonstration purposes, it doesn't really matter too much. But if you'd like to, you can just use the existing test CSV file. There's a module in scikit-learn that we can use to split our data, so I'm going to go ahead and say from sklearn.model selection, import train test split, and I use tab there to auto-complete that. If we take a look at the docstring for this, we can see that it splits arrays or matrices into random train and test subsets, which is exactly what we need to do. Then we need to create 4 new variables to house our train and test data for X and Y. The common convention for these variables is to call them xtrain, xtest, ytrain, and ytest. To save typing these out, we can go into our Shift tab documentation again, and from in here, we can actually just copy and paste these names from down here, which can just be a little time saver if you're typing these out quite frequently. We'll then just say that these variables are equal to the train test split function that we imported here. And this function takes in a couple of different arguments, which are the arrays, test size, train size, random state, shuffle, and stratify. Array is the data sets that we want to split. Test size and train size determine how much of the data will be used for testing and training respectively. We only need to set one of these, as the other will automatically be set to the complement of the other argument. For instance, if we set our test size to be 0.3, then train size would automatically become 0.7. Random state then just sets a seed for random number generation, which makes sure that we can get the same split each time we run our code. Shuffle tells the function whether or not to shuffle the data before splitting it. And finally, stratify is used when we want to maintain the same proportions of classes in both the training and testing sets as we have in the original data. But don't worry about these last couple here. In most cases, we'll only be using the arrays argument for our X and Y data, as well as the test size and random state. For this example, we'll set the first of our array arguments, which is X, to be our train dataset, but with the survived column dropped. So this now represents all of the input variables for our model. And then for our second array argument, which is our Y data, we'll say that this is just the survived column from our trained dataset, which is the target variable that we're trying to predict. Then I set the test size to be 0.3, which specifies that 30% of our data will be allocated to the test set, leaving 70% for the training set. And finally, I set a random state of 150, which sets the seed so that we can reproduce our results. I'll also just quickly copy over the explanations for each of these parameters so that you can read what each of them do. Okay, and great job there. We've now split our dataset into training data and test data. The next job is to actually create and train our model. We're creating a logistic regression model, so we can import this from the linear model module from scikit-learn. We'll say from sklearn.linearModel import logistic regression. Next, we'll actually create or instantiate our model, which to do this, we'll create a variable to assign it to. I'll just call mine logistic_reg_model, and I'll say that this is equal to logistic regression with a max iteration of 1000. In a very simple sense, by setting the max iteration to 1000, we're telling our model to try up to 1000 times to find the best solution. From a slightly more technical perspective, the best solution is determined by something called the convergence, which here just means reaching a stable solution where the parameters of the logistic regression model, or the coefficients, no longer change significantly. But this isn't too important for us now, so I'm not going to go into too much more detail on this. If you are interested though, then please post any questions that you might have down in the Q&A section. Then we're going to train our model, which we'll do by calling the fit method on the logistic regression model variable that we created here. All it does is train the model by fitting it to the provided training data, which in this case we'll say is our xtrain variable and ytrain variable that we created when we split our data. Xtrain consists of our actual training data, so the features and predictors that we're using, and then ytrain is for the correct labels, which here is the survived column, as we can see from both of our data frames here. Now that we've created and trained our model, we're going to use it to create some predictions. I'll say that y_predict is equal to our model, and then predict using our x test data, because we want to predict our results using this variable. Okay, great. And that's literally it. With those few lines of code, we've now created and trained our model. All that's left to do now is actually test it and see how well it performed. And in terms of the amount of code that we've written here to create our model, this is actually pretty representative of the work that you do as a data scientist. The majority of the work comes in cleaning and preparing the data, but of course there will be situations where you need to create and tune much more complicated models as well. The libraries that we're using here abstract a lot of the setup and work involved in actually creating the models. So all we need to do is provide it with the data. And now let's finally test our model, which we can do by importing the classification report function from the sklearn.metrics module like so. And basically, what this function does is give us some information relating to the precision and accuracy of our model. We'll say print, pass in our classification report function, and then to this, We'll then pass in our y test variable, which is the accurate and correct data, and then our y predict variable, which is the data that our model has predicted. This will then return the precision, recall, F1 score, and support for each category. Again, I'm not going to go into too much detail on these, but as a solid overview, so that you can interpret what this is telling us, the most important two are the precision and accuracy. Precision is how often the model was right, and accuracy is the overall correctness of our model. Given the small size of our dataset, this model has turned out really quite well, with an overall accuracy of 83%, meaning that our model predicted the correct result 83% of the time. We could further improve this by providing it with more parameters, which we could do by carrying out some additional feature engineering, or alternatively, we could also just provide it with more data, which in this case we could do, as we have both our raw test and train CSV files. If you're interested in machine learning, then feel free to experiment around with this and see if you can bring your accuracy up any further. If you do, I'd love to hear about what you did, so please share it down below. Okay, so that wraps it up there for this section. We've had a really solid overview, an introduction to machine learning. We've cleaned and prepared some data for our project, which was downloaded from a real machine learning competition on Kaggle, and then we've created and trained our model, which came out with an overall accuracy of 83%. And really great job here, you're doing really well. Let's go and take a well-deserved break, and then I'll see you all back in the next section, where we'll begin learning about SQL.